Now there's a lot of questions we'll see where we need to find the maximum or the minimum displacement. And remember, displacement is x, and it's measured in terms of t, where t equals time. So as an object is travelling, and remember we're only looking at it travelling in one direction, either it's going back and forth along a number line, or perhaps just in one direction, or it's going straight up or straight down. It's not moving around in 2 or even 3 dimensions. Now, if we want to find its maximum or its minimum displacement, it makes sense that when an object is not moving at all, its velocity will be 0. Now, we know that the velocity is the first derivative of displacement. So let's consider this. The time when the velocity is 0 will happen just for a moment when an object changes direction. So picture a ball at the top of its flight. If I've thrown it straight up, for a moment when it reaches its zenith or its high point, it's stopped before then it turns around to come back down. Or if I bounce a ball, then that moment of impact with the ground, it changes from going down to going up. And just for a moment, it's stationary. Now this is actually what they mean when we've been talking about stationary points for months. And yet it makes a lot more sense once we've put it in context here. Something is actually stationary at a stationary point. Now, to find our maximum or minimum displacement, it's a two-step process. We need to find velocity, and we find that by differentiating the displacement. And we need to let it equal 0 to find that moment when it's stopped. And then we need to solve for t. Now, your formula for velocity will be in terms of t. That means when you solve it for t, you're only finding when it was stopped. You weren't finding where it was when it was stopped. So the first step is to find when did this happen? At how many seconds into the experiment did this happen? And then you have to sub that value of t, which is a unit of time, back into your displacement formula to find what that actual maximum or minimum value of x actually was. So first step, find when it happened. Second step, find where it happened. Now remember also that if you've just found a formula for velocity and you've let it equal 0 and then you've solved it, it might be a maximum turning point or a minimum turning point. Now your question will probably let you know what makes sense. If you've thrown a ball up in the air, it's going to be a maximum turning point, and if you've bounced it onto the ground, it's a minimum. But sometimes things bounce up and down and up and down. So it's still necessary mathematically to prove that your point is a maximum or a minimum. How do we do that? Well, the proof for the maximum or the minimum can be done in two ways. Either you do a table of slopes where you show that the gradient of the displacement, in other words, the velocity itself, was positive and then it was 0 and then it was negative again, and that tells you it's a maximum point. Or you show that it was negative and then 0 and then positive, so it must have been a minimum. Or you can look at the second derivative. And if you look at the second derivative, you'll actually be looking at the acceleration. But instead of thinking of acceleration and getting confused, you'd find the second derivative, and if it's positive, you've got a point like this with upwards concavity, and if it's negative, you've got this, and so it must be a maximum in this case or a minimum in that case.